Welcome to follow up. Let's have a look at problem 2728. Count houses in a circular street. This problem is marked as easy by leetcode. However, this problem is an interesting one in the sense that we can understand Python classes and class methods. So, in other words, it's related to object-oriented programming. So let's have a look at this problem statement, and then we're going to share two formats of solutions. Essentially, so we just need to use some simple strategy and do the counting in a for loop or while loop, as we in a wide sense. So here we are given an object called street, which is a instance of the class object class street. So that represents a circular street, and also we are given a positive integer key, which represents a maximum bound for the number of houses in that street. So this piece of information actually is very crucial for the counting. So the houses doors could be open or closed initially. We don't know, but some might be open, some might be closed, or all open or all closed. But all the cases are possible. So initially, we are standing in front of a door to a house on this street, and our task is to count the number of houses in the street. So here, the class street contains the following functions. So one is an open door, and the other is closed door. These two returns nothing, right? So another function is a boolean. Is door open, right? Checks if the door is open or not. Actually, it serves as the same function if you have a method called is door closed, right? So one is sufficient. So also they have two actions called move right and move left. So these actually are also important. So we can use one of them, right? We just take one direction in the coding part. So we need to return the number of houses in this on this street. So here are two examples. The first example, the houses number, the number of houses is 4. And notice that k here is 10. So this 10 actually is much larger than this total number of houses in this example. In the second example, k equals to the number of houses, right? So in this example, the output is 5. So before we look at the code, let's also look at the constraints. So here, n is the number of houses. N will be bounded above by k, and k is bounded above by 10 to the power 3, right? So with that said, basically we are ready to do the coding. So for this problem, actually the hint is very suggestive. So if you look at the hint, actually it's easy for us to come up with a solution. So here the hint says that you can close all the houses and then move in one direction, and then you open the current house and move in one direction and count until you reach a house with the open door. So you can do the reverse also, right? You open all the doors and then close the current door and then move in one direction until you reach a house with the closed door, right? So that's basically the main idea. I guess the main problem for this problem is to be aware of how to use the method in the class. So here we are going to provide two solution formats. So essentially they are the same solution, but one is sort of brute force and the other is with an early stopping. So first I'm going to close all the doors, right? So here the k comes into play because k is an upper bound for the number of houses, right? So we just need to close k times. So this will make sure all the doors in a state of closed state. So basically we can use a dummy index for for this dummy index in range k. So we want to do the close operation for k times and along one direction. So here we are going to notice that this is then street object, right? We can call this closed door method, right? And then each time we close the door, we are going to move in one direction. So we can do straight move right. Let's see, right? So here you can move left, but the thing is that you just need to make sure you move along one direction. So this for loop actually closes all the door. And then we do the counting, right? Let's do the counting. So one way to write this is the following. So for this dummy index in range k, right? And then what we are going to do is we check if because we have closed all the doors, right? If is door open. So if we haven't met a door that is in the open state, so we are going to increment the answer by 1, and then we are going to open the door, right? Open door. And then anyway, so we can move along one direction. Here again, let me move to the right. So this way, after we do the two for loops, so this first for loop close all the doors, and then we along one direction we open the doors, because the street is in a circular fashion. Once we meet a door that is open, so we can actually stop, right? But here actually we didn't use that stop condition, because we just count along this for loop of length k, right? So now let's return the state. Before we make any adjustment, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let's make an observation based on example 1. So here in the second for loop, actually we did some extra work. So we just need to count the number of houses. We don't need to use a for loop of length k. For example, in example 1, the k can be much larger than the street, right? So in the first for loop, we need to make sure all the houses are closed or opened. So this way, we need to have a upper bound that makes sure that is larger than the number of houses. That's the row of k. But for the second for loop, we don't need that. Let me copy this part and make a slight adjustment. So I'm going to mark this one as version v1, and then we didn't change the first for loop, but in the second for loop we're going to make some slight adjustment. So each time we meet a door, this is still in a closed state, so we increment the counting, and then we open the door, and then we move to one direction. And afterwards, or else, if we meet a door that is already open, it means that we have already done the traversal in the length of the number of houses. We just need to break, and then we can return the answer state. So this way it saves some iteration. So now let's do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes the generic case. So that's basically about it for this specific problem. So here the main point is to familiar ourselves with the class and the object and the methods in the class. So with that said, that's it for this video. Thank you.